Hello everyone and welcome to Teche.
So have you ever run into this? You're a developer or maybe a network engineer and you see a connection that just refuses to die, right? It's just sitting there on your server, eating up precious resources, causing all kinds of headaches. Maybe you've seen a server that gets slower and slower all week, and then you finally check and realize it's just drowning in thousands of these zombie connections. Figuring out why this happens, well, it's not just some textbook problem. It is absolutely key to building systems you can actually rely on.
So in this explainer, we're going to demystify TCP connection termination for you. We'll kick things off by looking at those pesky lingering connections, and then we'll dive right into TCP's graceful four-way handshake, the proper way to say goodbye. We'll break down why it takes 4 steps, what goes wrong when the process fails, and we'll even look at the more abrupt way to hang up. And finally, we'll tie it all together to show you why this is so critical for building solid applications. Let's jump in.
All right, so let's start with that all-too-common frustration, the lingering connection. You think you've closed your app, or a user has clicked away from your site, but then you run a command like netstat on your server, and boom, the connection is still there, just stuck.
The usual suspects you're going to see are states like close wait, fin wait 2, and time wait. Now they might look like errors, especially when you see a whole bunch of them piling up, but they're actually normal, necessary parts of the TCP protocol. The best way to think of them is not as bugs, but as symptoms, clues that are telling you a story about how a connection is trying and sometimes failing to end.
And look, let's get this out of the way right now, because it's the most important takeaway. When you see a connection that's been stuck in a state like close wait for way too long, the problem is almost never the network itself. Nope, it is a massive red flag and it's pointing straight at a bug in your application's code. It usually means your code got the signal to close the connection, but it just didn't do it properly. Maybe someone forgot to put a socket.close and a finally block, or some error path just skips right over the cleanup. And that, right there, is where your real debugging journey begins.
So to really get what's going wrong, we first have to understand what right looks like. And that brings us to TCP's formal, very polite process for ending a connection, the four-way handshake.
The four-way handshake is basically TCP's protocol for a graceful shutdown. The main idea here is pretty simple. It lets both the client and the server finish up their conversation and close their end of the connection on their own time, making sure no data gets lost in the process. It's all about reliability.
So, at a high level, this is how it works. Imagine your browser has just finished loading a web page. First, your browser, the client, sends a fin, or finish packet. It's basically saying, hey, I'm all done sending data. The web server acknowledges this with an ACK packet, saying, loud and clear. Then, once the server is also finished sending all the page content, it sends its own fin packet. And finally, your browser acknowledges the server's fin with one last ACK. And just like that, the connection is cleanly and completely closed, a polite little back and forth. And this diagram shows it perfectly. You can see how those states we talked about map directly to each step of the handshake. The client sends a fin and goes into fin wait 1. The server acknowledges it and enters close wait. When the server's done and sends its fin, it moves to last ACK. And finally, the client sends its last ACK and enters the time wait state to wrap things up safely. See? Every step has its own state.
Now this brings up a really good question. If setting up a connection takes a 3-way handshake, why does tearing it down take 4 steps? Well, the answer is baked right into the nature of TCP itself.
You see, TCP gives us what's called full-duplex communication. The best way to picture this is like a 2-lane highway. Traffic can flow from the client to the server in one lane and from the server back to the client in the other at the exact same time. They're completely independent. And because those 2 streams of data are independent, they have to be shut down independently. You've got to close one lane of traffic, and then you close the other.
So let's compare. During that initial 3-way handshake to start a connection, the server can combine its I'm ready signal, the SYN, with its acknowledgement, the ACK, into a single packet. Super efficient. But during termination, the server's acknowledgement of the client's fin and its own fin are sent as 2 separate packets. So what's the deal with the extra step?
Okay, so here's why that separation is absolutely crucial. Just because the client says, I'm done sending, that doesn't mean the server is done too. Think about it. Let's say you just finished uploading a huge file, and your browser sends that fin packet. The server immediately replies with an AK, basically saying, yep, got your file, all good. But the server might still need to send you something back, right? Like a success message or transaction ID. This creates what we call a half-closed state. The lane from you to the server is closed, but the lane from the server back to you is still wide open. It's only after the server has sent its final piece of data that it sends its own FIN packet to finally close its side of the road.
All right, now that we know what a proper, graceful goodbye looks like, let's circle all the way back to our original problem, those connections that seem to get stuck forever. Now we can figure out what those states really mean with a lot more confidence.
Let's start with the infamous close wait. A server gets into this state right after it acknowledges the client's FIN. The name says it all. The TCP stack is literally waiting for the application running on the server to finish up and call close on the socket. If a connection is stuck in close wait for hours or even days, that's a resource leak, plain and simple. Each one of those connections is holding on to a file descriptor and memory. A few isn't a big deal, but thousands can bring a system to its knees. And again, this is almost always an application bug.
So what about time wait? This state happens on the side that started the close. In our example, the client, right after it sends that final ACK. Now, seeing a lot of connections in time wait on a really busy server might look scary. But unlike a long close wait, this is not a bug. In fact, it's actually a sign of a healthy system that's closing a ton of connections properly. It's an essential safety net for network reliability.
The connection hangs out in this state for a period called 2MSL, which is twice the maximum segment lifetime. In simple terms, MSL is the longest a single packet could theoretically get lost wandering around the internet before it's just dropped. This is usually set to about 2 minutes, so the time wait state typically lasts for a few minutes. But why that specific amount of time?
Well, the time wait state does two incredibly important jobs. First, it makes sure the server actually got that final ACK. If that ACK gets lost, the server will time out and send its FIN again. Because the client is still patiently waiting in time wait, it can just resend the ACK, guaranteeing a clean shutdown. Second, and this is a big one, it prevents old delayed packets from the connection that just closed from messing up a brand new connection that happens to reuse the same ports. It's like a mandatory quiet period, letting any stray packets from the old conversation fade away before a new one can start.
So far, we've only talked about the polite, graceful way to end a conversation. But what happens when you need to end it now, with no time for goodbyes? Well, that's where the TCP reset, or the RST packet, comes into play.
This analogy is just perfect. A FIN packet is like saying, "It was so nice talking to you, take care, goodbye." An RST packet, that's like slamming the phone down in the middle of a sentence. It's immediate, it's forceful, and it's usually used when something has gone wrong.
Let's put them side by side. A FIN kicks off that graceful 4-step dance we talked about, making sure all data gets there safely. An RST, on the other hand, is an abrupt close. It tells the other side to immediately tear down the connection, release all its resources, and just forget it ever happened. The catch? Any data that was in transit is just gone. You'll see this when a system gets a packet for a connection that doesn't exist, or when a firewall wants to block a connection cold.
Okay, we have gone deep into the weeds of TCP states and handshakes. So let's pull back up to the big picture. Why does any of this really matter? Well, it's all about building applications and systems that are strong, reliable, and don't just mysteriously fall over on a Friday afternoon. So let's quickly recap the key takeaways here. First, proper connection termination isn't just about being polite. It's absolutely essential for preventing resource leaks that can bring your servers to a halt. Second, if you see a connection stuck in close wait, your first thought should always be an application bug. That's where you start digging. Third, understanding these states is like having a roadmap for debugging network problems. And finally, just remember that the most reliable systems are built on the foundation of a graceful goodbye.
So that leaves us with a question for you to think about. How will you approach handling connections in your next project now that you know exactly what's happening under the hood? Because building great software isn't just about making things work, it's about making them work reliably right up to the very end of the conversation. Thanks so much for joining us for this explainer. If you found it helpful, a like and a subscribe would be absolutely amazing. We'd love to hear your thoughts or questions down in the comments below. We'll see you next time on Tech.